a little short on time on Friday, which was unfortunate because I was really excited to analyze through the looking glass, but we're going to finish it up today. We have, it's been a few days, so let's kind of review where we left off. This was our first example of writing code that used the set data structure. And so today we'll implement the read words method, which returns a reference to a set. And so we're going to have a set of words that are in our dictionary. That's in this file here called words. And we're going to have another set of words that's in our novel. And the novel we're analyzing first, at least, is through the looking glass. We explored how we can use an enhanced for loop to iterate through a set in no particular order that makes any sense to us, at least. We can use the contains method as well on the set, which is very, very efficient. We can see how many elements are in the set with the size method. We can use an iterator. This is not a list iterator because this isn't a list. This is just the capital I iterator, the more generic iterator. We can use the iterator to go through the list. Same structure, even though the type is different, it still has next and next within the loop. Here we're removing words that are less than or equal to 3 letters in length. And then we see how many words remain. And so what we need to do is implement this read words method, and then we can actually run this thing, which will be great. So let's jump into that. So we've already got a Java doc header here. This method is going to read all the words from a file, takes one parameter, which is the name of the file. It returns a set with all lowercase words in the file. So we're going to make sure that we get everything into lowercase. We define a word to be a sequence of upper and lowercase letters. Like that's our definition of what we mean by a word. So not like numbers and things. Nope, we don't want punctuation, anything like that. So we'll get rid of the return null and we'll actually like do something. So let's write a comment block to explain what we're going to do. One thing you may remember from last week is when it comes to a set, we have 2 choices. We can use a hash set or a tree set. Hash sets are faster than tree sets. So by default, we want to use a hash set unless it's important that when we iterate through the set, it's in sorted order, in which case then we would use a tree set. We don't care about that in this case. So let's get the performance benefit of using a hash set. So we'll say the implementation of the set doesn't matter. So store the reference in a variable of type set. I'll explain more what I mean by that sentence in just a second. We don't need to iterate through the set in sorted order. So create a hash set because it is faster. The hash set is like order 1 for all of its operations. So this is a best practice that is new to us in this course, and that is being more intentional with the types of our variables. Okay. So in AP Computer Science A, we would have written this line of code as like hash set words equals new hash set. The type of the variable always matched the type of the object we were creating. And I think that made a lot of sense in AP Computer Science A because it was a simple to follow rule. We're like, okay, got it. That makes sense. But better practice in Java is that you want the type of your variable to be the most generic type that still supports like the methods you want to call. The hash set and the tree set have the same methods. There's no point in having the variable of type hash set. Having the variable of type set works just fine. And the reason why this is best practice is it gives us flexibility. Because the read word methods returns a variable of type set, because all of this code up here deals with variables of type set, Let's say later we found it was advantageous to be able to iterate through the set in sorted order, and we wanted to change to a tree set. If we follow this practice, we change one word in our code to tree set, and everything else still works, and we get the behavior we want. Okay. If instead we had littered hash set throughout all this code, we would have to change every instance of set to hash set, and it would be tedious and error prone. So that's why we tend to have variables of a more generic type. You'll see as we work through stuff in this unit, I will often create variables of type list rather than like linked list or array list, because they have the same methods essentially, and we don't need to distinguish between them. All right, so we have a new hash set. We need to read in a file, and so we can do that with scanner. Um, I don't know if you ever use scanners in AP Computer Science A to read files. Do you? Is that a thing? Maybe you read from like system.in. You definitely do that. We're going to read from a file. So I'm going to say new scanner, and you're most familiar by specifying system.in here as the parameter to the constructor. We're going to specify a reference to a file. So inside the parentheses, I'm going to say new file, and I want to create a new file object that refers to the specified file name. And I need to specify how that file is encoded. So text files can be encoded in different ways. That's why this parameter is called the char set name. Ours is UTF-8. And this is like a Unicode type format. And we're using 8 bits per character in terms of how the file's encoded. Java can often figure that out on its own, but not always. So we're giving it some help here. When we read this file, by default, I know it's been a while, if you think back to scanner, scanner returns words or tokens that are separated by white space, spaces, new lines, tabs. What that means is we would get a word, but that word would include like a comma and a period and maybe like a digit. We don't want that in our word. We don't want punctuation. We don't want numbers. We just want like the real word, the letters. So we're going to change how scanner behaves so that we get words and we don't get the punctuation and the spaces and everything. So what we want is we want to use any character other than A through Z or capital A through Z as delimiters. Delimiters was one of those like technical vocabulary words with scanners. The delimiter is what determines what breaks like the whole file or the whole string into tokens. Um, so we're going to actually specify a different set of delimiters than the default. So I'll say in.useDelimiter, and my pattern will be this thing. And we'll talk about what this means. Whew. On our daily agenda page, under extensions, there's a link to something about regular expressions. Regular expressions are not specific to Java. I believe they had their origin back in a very early version of Unix. Regular expressions is like its own little like syntax code for specifying patterns of characters to match or not match. And so I'll tell you what this one means, but the extension resource is there because learning regular expressions can be really helpful. Um, Very often you can use regular expressions to search for things, and you can have much more powerful searches using regular expressions. And there's tools that you can use for search and replace with regular expressions. I use it surprisingly often, especially as a teacher, but what this pattern means, so square brackets means the set of characters that I'm going to specify. The caret character here means match everything except what follows. And what follows is the character A through the character Z, so I don't have to type them all out, and the character capital A through capital Z. So this part right here means match a character that is not, think of the caret as like a not, match a character that is not A to Z lowercase or A to Z capitalized. And the plus means match one or more of these. Okay. So as a delimiter, if there were two spaces between words, this would match that because a space isn't a character A to Z. If we had a period and then a space, that would match as a delimiter because a period isn't between A and Z, nor is a space, and then we can match one or more of them together. So that's what this delimiter will do. So as a result, when we call next on our scanner, we'll get just words, just letters, and none of the punctuation, none of the spaces, none of the numbers. So we're going to use a while loop just like we have been with an iterator, which is also like what we did last year with scanner. And we'll make an important comment here, which is adding duplicates to a set is ignored. So is removing elements that, hey, all good. So is removing elements that don't exist. That don't exist. So there's no point in us checking if the word is already in the set. That would just make our code slow. We're just going to keep adding the words over and over and over again. There's no harm in doing that. And in fact, it's faster than checking. So we'll just say words.add. What word do we want to add? Well, the next word that we get from scanner. So in.next, but we want to change it to lowercase. Another thing I wanted to share and just check that we're comfortable with this. When I've taught AP Computer Science A, I tried really hard to do one thing per line of code because I felt like that made it easier for students to track what was going on. So I would never write a line of code like 76. I would say like string word equals in dot next. And then I would say word equals word dot to lowercase. So I first read in the word, then I convert it to lowercase. Then I would add it to the set. I would spread this over 3 lines of code. Okay. At this point, we shouldn't need that like level of like support and specificity. Um, just, pay attention to your parentheses and read left to right and be like, oh, I'm getting the next word from the scanner. I'm converting it to lowercase. I'm adding it to my set of words. Cool. And I can do that all on one line of code. And then we can just say return words. So that's the entire implementation of the read words method. So once you have this, scroll back up, click run, and it will perform analysis of the entire book through the looking glass based on our dictionary. I'm going to run it too. So there are 3,260 unique words in Through the Looking Glass. 2,999 of them are greater than 3 letters in length. And look at all of these words that aren't in our dictionary. Now, some of them are like page numbers in Roman numerals. That's what these are. Some of them are like British spellings, but a lot of them are the made up words that Lewis Carroll loves in his writing and poetry. So, like galumphy, right? So, this is from the poem Jabberwocky, right? Goes galumphing back. Like he makes that up. That's not a word. Beamish, There's Jabberwocky. Mimsy. All Mimsy were the Borogroves. Where are Borogroves? That's a made up word too. That'll show up here. All sorts of made up words. Gyre and Gimble in the Wabe. That's part of that same Jabberwocky poem. All full of words. There's Borogroves. So lots of made up words. Some of this is from other this is part of Project Gutenberg, like open source free texts that no longer under copyright. And so like ASCII does not show up in the text through the looking glass, but it refers to like how the novel is there. So kind of cool to see all the words that are made up in here or have different spellings. Like color, there's the British spelling of color. Favorite, same thing. Honor, all those OUs. So question, yes. Getting an exception? Let's take a look.